Now we can think of risk aversion in the following way. If a consumer is facing two possible outcomes, X and Y, and we could think of these as monetary outcomes, cash if you like, given the following utility function. This should go through the intersect. Here is the utility of X. And here's the utility of Y. Okay. Now if I consider a lottery where I am getting X with a probability P and Y with a probability 1 minus P, what is the expected value of this gamble? Let's pick P equal to 0.5. So expected value will be right here, right? This is Px plus 1 minus Py. Now the utility of getting this particular amount, of getting the expected value, is here. So this is the utility of getting Px plus 1 minus Py. Okay, now we may ask the following question, which is, well, what is the expected utility of taking on that gamble? So instead of getting the expected value for sure, if X were equal to 750, for example, let's just jot down some numbers. If X is equal to, 500, and Y is equal to 1,000, and if P is equal to 50%, what is the expected value of getting Y with a 50% chance and X with a 50% chance? Well, the expected value here is 750, right? 50% of 500 plus 50% of 1,000. So 750. So this number here is 750. So the utility of getting $750 is measured here. The question that we ask now is, well, what is the expected utility of taking on that gamble? So instead of getting $750, I'm getting either 500 or 1,000 with a probability of 50% each. Well, expected utility theory tells me that the expected utility of a gamble is a weighted average of the utility of each outcome. In other words, I'm going to be somewhere on this line here, which is linear combination of ux and uy. And specifically, the utility of taking on that gamble is going to be in the middle, right here, for P equal to 50%. So this level right here, that is simply the utility of the lottery, which is none other than P times u of x plus 1 minus P times u of y. Risk aversion is simply the idea that the expected utility of the gamble, that number that we've just looked at right here, is going to be less than the utility of getting for sure the expected value of the lottery. So let me rephrase this. The utility of the expected value, right? So if I consider the expected value given the probability of getting x and given the probability of getting y, and if I look at the utility of the expected value, this is going to be greater than or equal to the expected utility of the gamble, which expected utility theory tells us is none other than a weighted average of the utility of each outcome. So P ux plus 1 minus P uy. All right, so this is expected utility theory. And this is simply the utility of not the gamble, but the expected value of the gamble. Now you'll note that according to expected utility theory, the expected utility of a gamble is a function of the utility associated with each outcome. The utility of the expected value of the gamble is not, right? So here's the expected value of the gamble, and this is something that we're assuming that we're getting with certainty, and we're just looking at the utility of getting this amount. So this is risk aversion in a nutshell. Risk aversion tells us that the utility of the expected value of a gamble is greater than or equal to the expected utility of that gamble. Now in continuous form, using a continuous variable, we can restate this result as Jensens inequality. So if you consider the following, given a cumulative distribution function, which is as follows. Okay. Small f of t here is a density function. We can write that the utility of f is the following integral. Okay. Now, risk aversion simply becomes Jensens inequality, which is that the weighted sum of the utilities is going to be less than or equal to the utility of getting the expected value here. Okay. Now another question I could ask here is, what is the amount of money which gives me the same utility level as the gamble right here? So here is the utility that I am getting. This is the utility of the gamble, so it's simply a function of u of x and u of y appropriately weighted by probabilities. What is the amount of money down here, right, which gives me this utility level? Well, it's going to be found right here. So this is the amount. This is called the certainty equivalent. The amount of money which gives me the same utility level as the gamble, right here. Another remark worth noting is that risk aversion can be measured by the concavity of the utility function. You can see that the greater the concavity of the utility function, the greater the differential here between the utility of the gamble and the utility of the expected value of the gamble. So this differential here will increase with the concavity of the utility function. Now this brings us to a final point, which is that we can define a measure of risk aversion, also known as the absolute risk aversion, the Arrow-Pratt measure of risk aversion, which is related to the curvature of the utility function, which is as follows. Absolute risk aversion is simply the ratio of the second order derivative of the utility function over the first order derivative of the utility function. And the reason that we divide here by u prime is simply to make this ratio invariant to positive linear transformations of the utility function. So if, for example, we multiply the utility function by some parameter, for example, the number 2, we will still represent the same preferences, the same underlying preferences. In other words, the consumer's behavior doesn't change, but here u double prime would change. And so in order to correct for this, we divide by u prime to make this ratio invariant. We can also define the relative risk aversion. Now, with absolute risk aversion, the outcomes are conceptualized as absolute gains or losses in terms of absolute amounts from current wealth. But instead, we can also evaluate outcomes as gains or losses in terms of percentages of current wealth. So this is the idea of relative risk aversion, which is the following. We could define a utility function, which is defined over t, which is a percentage of wealth, and this is simply the utility function of this percentage of wealth times the wealth. So the absolute amount. Now, relative risk aversion can simply be thought of as the risk aversion, the absolute risk aversion of this function. So this particular ratio. The negative sign, by the way, I forgot to mention, is simply because we're thinking of risk aversion as a positive number, but the curvature of the utility function will be a negative number, so we reverse the sign. So we are looking at the risk aversion ratio, but now defined in terms of an underlying variable, which is t, which is the percentage of wealth. So let's look at this ratio. What is this ratio here? It's simply the second order derivative of the utility function, but with respect to t, over the first order derivative of the utility function with respect to t. So let's think a bit more about what this entails. Let's first figure out the first order derivative. Let's just apply the chain rule. Okay, so this is simply equal to, this here is simply x Okay. U prime of tx here is really simply u prime of x, in the sense that all we care about is really the derivative with respect to whatever is inside the function. The second order derivative now is equal to the derivative with respect to time of with respect to t, sorry, of x u prime tx, right, which is what we just obtained. And this is simply equal to the following. Okay. Now here, this again is equal to x. And this is the second order derivative with respect to tx, but again, this is simply the following, right? So now if we think of relative risk aversion as the absolute risk aversion defined over u of t, where we think of the utility of outcomes as a percentage of wealth, we have the ratio of the second order derivative over the first order derivative, which is here second order derivative and here first order derivative. And that ratio here is equal to this over this. The x's 1x goes away, and we have this result. Oops. Need the negative sign. Okay. This result right here that we've derived here is simply the relative risk aversion. So we have the same ratio as before, but we now multiply by the wealth amount.